and it's the third resistor. So power in, through, no ground, another, so first resistor across here. Yeah, what, oh, wait, yeah, exactly. Okay, so you said turn signal circuit, you said?
Yeah, he said he'll put a bulb in and it'll work, but it's real dim and then it quits.
What year is the Magnum?
5 or 6.
Which one, Danner? 06 Dodge 2.7 junk motor. So the right side, right front turn signal shares a ground.
Oh, the parking lamp don't work either.
Right front park turn lamp. So they share a ground, 2 filament bulb. We just need to do a voltage reading on these 3 pins right here. Yeah. That'll give us. So on this, this is the totally integrated power module. Let me scroll up a little bit. Front control module, sorry. Is the front control module different than the totally integrated power module? No, it's part of it. Okay, so integrated power module, and then the front control module supplies power on the white and tan wire. This is the bulb that we're being told is dim. It's grounded on the right front of the engine compartment, G101. And then the purple wire would be your parking light circuit. So that's why you have the same wire for the left and the right bulbs. Parking light, that comes from the parking lamp relay. And the left front turn is then also the front control module. So control module supplies voltage and grounds externally. I just want to get voltage readings right here on that right front bulb is where we want to start with that. 06 Dodge Magnum. Yeah, parking light's not even working. And they're shared, it's a shared circuit for the, from the relay for the parking light, so I'm not worried about the supply side. Let's turn the parking lights off and do the right front turn signal I just turned on. Yeah, this is gonna be a bad ground in my opinion. It is, look, this is a bad ground. Let me turn these lights off. We're getting feedback into the other side. Yeah, that's exactly what's going on. We got a bad ground. Here, come here. Get a shot of the right turn. It's nice and bright in the back. So nice bright light in the back. Here's my suspicions. We'll prove it, but if this ground is bad right here, when you turn the parking lights on, which is these guys, you'll have no light, right? Light's not gonna light for the right front parking light. I know we have 2 bulbs there and there's another one. We're not showing that on this diagram, I think. Again, this is my suspicion. Ground's bad. The reason this right front turn signal would work and also is blinking the left front, what's happening is we're sending impulses of power, on, off, on, off, on, off, turn signal. And what's happening is it's back feeding through this bulb, which is a parking light bulb, on its way over here, back feeding through this parking light bulb, and it's getting its ground over here. So you actually have 3 filaments that are being lit. This one, and this one are all being lit in series to each other, okay? Because that ground is bad. And that's why this one's super dim and this one's brighter, even though it's still dim, is you have 3 bulbs in series. The final one will be the dimmest. That ground's bad, G101. Does that make sense? I'm gonna show that one more time. This one's gonna look brighter because both of those filaments are lighting. This one, only this one's lighting. And it's the third resistor. So first resistor across here because there's no ground. Second resistor, which is another bulb filament this way, down here. Third resistor bulb filament going to ground here. Third one's gonna be the dimmest. Those 2 are lit, third one's the dimmest. Let's go look. I was incorrect in one statement. Both filaments are not lighting. Only the one is. You see the brightness of that one, compare it to this one. See how dim that one is? And so what I believe then, turn signals are always brighter. What I believe then is we're still going through both filaments here, but there's not enough current flow to light the turn signal part because it's a lower ohm circuit. That's what I think. I don't know why that's not lit, but it's not important. This is a bad ground though, for sure. Let me get my light. Okay, this is right up top. This goes right to my turn signal. This is loose. This bulb, those are the 3 wires we want to check. And harness side, the ground in particular is of interest to me. This is no good. I don't know what this is. That's no good though. Okay, real quick on the screen over here, Caleb. I'm just using my multimeter for my autel, and the reason I'm using this is we had it out already for some other tests that we were doing on a different car. And I just had this sitting here, and it's real nice for me to show you guys a screen because I can use a recorder. And what we're gonna use is the multimeter because it has a nice digital number there that you guys can look at, and just makes for nice viewing. This is the Autel Ultra that comes with a lab scope. The lab scope is built into the VCI, vehicle communication interface piece, and it's wireless. Talks to me here wireless. So you see I have nothing connected to this. That's the way the Autel sets theirs up. What we want to do for this test, I want to go to a known good ground, and the battery is not here. It's in the back. So I really want to be at the battery for this because I'm suspecting a bad ground. I'm going to go on this ground right here. That might not be ideal for our tests. We'll see the result based on what we have on whether or not we like that connection. As far as settings go, oh, that works. I'm on a 30-volt scale. Just going right at that black wire. We should have no voltage here, and that's exactly what I thought. The reason we're showing high-low voltage is that is a bad ground. Black wire should have nothing on it. Let's go on this circuit. That's the, looks like white with a tan. I have oscillating 5 to 7 volts. On the white with a purple, I have oscillating 1.6 to 2 volts, which explains why that bulb is not lighting, but that voltage is there. And then on my ground, the black wire, I have the same 5 to 7 volts. Let's go look at the wiring diagram again real quick. Yeah, the white tan, the white violet, the black with a dark green. The black with a dark green, I didn't notice it had a tracer on it, but that's our ground. Does this have a green tracer on it? Yes, it does. I did not notice that is in fact black with a green. Bad ground. So right now, if I would jumper that, just take a jumper wire from there to ground, we can fix this just momentarily. You got a jumper wire, Danner? Where do you keep them? In your nice clean area? This will work. I should be able to use this. So just gonna jump my T-pin and then reach it over to the ground itself. And what you're gonna see, as soon as I do that, the voltage is gonna drop on the scan tool, and then my light's gonna get bright on this side, as long as I'm making good contact. A nice bright light. We have some fluctuations because you have voltage changes as the light turns on and turns off. We have current flow changes, which explains your millivolt reading here. That's not a problem. And then if you look, try to get the camera on this, you can see both bulbs now. Just stay focused there for a second. It's the back filament. Watch when I take this ground away. You're gonna see the front filament's gonna be the one blinking on and off, because it's back feeding. The back filament, we're not getting enough of a voltage drop with that bad ground to light it, but it's enough to light the front bulb. That's your parking light bulb. And I was right in what I said. It's going through 3 resistors. And you see that one over there one more time, how dim this is. Stay focused on that one. Tell me when you have it. And now when I ground this over here, you're gonna notice that's gonna go out. That's not gonna be lit at all because we now have a complete circuit. It's a backfeed. Classic backfeed with shared parking turn signal circuits. I'll show you one more piece. That's gonna be the parking lights themselves do not work. So let me shut the turn signal off and turn the parking lights on, nice and bright. Over here, got nothing. Notice my ground voltage is at 12 volts. Completely 100% open ground. And then show you my voltage readings on the circuits. 12 volts on the white and tan. We're gonna have 12 here too, because it's gonna backfeed on both bulbs. That's the white and purple. Yeah, the white and violet. Well, the reason we're reading 12 on that one, talking about pin 2 on the right front turn signal. The violet white's reading 12 because the black and dark green has no ground. Power comes in on the white and tan, which is this one, which reads 12, comes through that bulb, can't go down the black and dark green, and it's coming back up and out on this side. That's why we read 12 there. The other thing is, remember where the turn signals were actually working. When the right front turn worked, it worked because it was getting its ground through the left front. With the parking lights on, it is not going to be possible to get the back feed. So when the parking lights are on, we're going to have nothing on the turn signal. So parking lights and left turn, right? Parking lights right now, you see no parking lights on the right front. If I turn the right side on, that's the right turn signal is now on. You got nothing going on over there. But if I go in the back of the car, I do. Right rear turn signal's working fine. And so it's blinking fast because we're missing a bulb. And then you see the parking lights are also working fine. Although we do have a couple of LEDs that are out on this one. That's not an issue. Everything's good back here. Let's go back up front again. Parking lights off. Right front turn signal is on. And you see that you see both bulbs? So what's happening, turn signals on, parking lights off, we're sending 12 volts down here, right? This ground is bad. Can't go that way. Again, so it comes this way, up and over, down this way, finding a ground through the parking light circuit. It also can find a ground through the parking light circuit on other bulbs. Again, that is why this bulb is lighting dimly on the left side, and it's also dim on this side too. Now that's with just the turn signals on. If I leave the turn signals on, turn the parking lights on, now what just happened is we have no activity at all because we're now sending 12 volts down the parking light circuit, 12 volts over this way. And so that's a very poor picture, hold on. 12 volts is coming this way. And so the 12 volts that was coming down pulsing on the turn signal can no longer backfeed this way because what's 12 and 12 do? 12 and 12 doesn't do anything, no current flow. 12 volts coming one way, 12 volts coming the other. We've lost our ground is what happened, which is why when the parking lights are on and the turn signal's on, we have nothing over here. But when the parking lights are off, we lose that 12 volt over there, and then we have the back feed that is now allowed to take place. This ground is good on the left front. This ground is bad right there. We need to find it. Okay, so what I need to do is I need to find this ground. It says at right front of engine compartment. I wonder if that's like where I connected that. What do I have on right now? Parking lights, that works. We'll use the parking light to finish troubleshooting. It said right front, I mean, that's where I'm connected. It could be legit like that ground that I'm connected to, and it's one of the wires in this. I need to double check. Let's go to the diagram real quick. G101 says at right front of engine compartment. Let's go find that ground. We go to ground distribution. G100. G101 at right front. So I want location though. So that is the fender. It is not the area we were just looking at. It's down along, what is that? I think it's down, okay, it's not the ground that we were connected to. Let's go look in that area. Yeah, this is the one that was bad on the other car that we worked on. That's the ground location. So the bad part about that location is that this freaking washer bottle's in my way, and we're gonna have to take the inner fender off, take the washer bottle out, get that out of the way so we can work with that, or we take this headlight assembly out and get to it that way. Let me see if I can put my hand down on that. Let's go back to the ground. We'll re-ground my scope over here. Show you 12 volts in that location. And then I'm gonna put my hands down there, or my light down there. I'm gonna wiggle the wiring. So I'm just gonna reach down and kind of touch these wires, move them a little bit, see if we see some voltage changes. No changes, surprised by that. Pretty sure that's it. Just gonna try to snug it, see if we get a voltage change. I don't at all. Just worried that maybe I'm either A, on the wrong spot. We have absolutely a broken wire right there, and I can't really tell. I don't want to take all that apart unless I'm sure that's where that ground is. I need to go look again. Oh, okay, it is a top view. Okay, it is those two. It's exactly where I am, right there. See the nut, they're showing the nut. Okay, then we need to work in that area. I gotta pull that apart somehow. I'd rather not take the inner fender and the washer bottle out just yet. Yeah, it might be hitting. I need to take this light out. That harness is hitting right down there is where I think the damage is. I don't think it's the eyelet itself. I think the harness got cut into that. And I don't want to run a new ground. I want to prove it. Here, I'll point to it on where, with the screwdriver, Caleb. I'm just worried. I'm worried about this harness right here, hitting in here, that cut some wires. I mean, we still could have a bad ground, but I'm worried about that harness right there. This is the harness right here that I'm worried about. I'm not seeing it. So, take the damn washer bottle out. We're gonna lose all this washer fluid. Yeah, the area I'm concerned about is right here. I was worried about the harness down here too, but it's not rubbed through now that I can get my hand on it. So now I want to refocus back on these grounds. I kind of need to open that up. Unbolt it maybe is going to be the best way to do that. Hate to do that this way. Kind of want to show you guys the voltage drop. Okay, I need some jumper wires because I want to ground these two eyelets, and then I want to play around with these, see if I get my voltmeter to change. I'm just grounding this so I can do some voltage drop measurements. That's the plan. Okay, 8 volts on that one, and nothing on that one, so that kind of tells me that it's this one. Yeah, it's gonna be this one. That one's got 8.8 volts on the end right there. It means it's probably bad right here. And this one has nothing. So I'm gonna focus on this guy. We'll ground it. And then I'm just gonna back probe this, like this black-green, heavy black-green wire right there. There it is, it's bad right there. Oh wait, sorry. Let's connect that back up. My jumper wire. 1.1 millivolts. That's good right there. Where's the ground pad at? Double check this one again. We should have 12 volts on this whole assembly. We don't. That doesn't mean I should have a broken wire in here. One of these guys, because this is a real heavy one. So the reason I'm not reading 12 at the tip is I believe that we have a break right here. There it is, right there. Probably one of many. Okie dokie. So let's ground that and ground that. We'll just ground this one for now. I don't know that I need this one. And then I will show you. This is the black and green tracer on the light. Got 12 volts on that. And if I strip this back and then touch that on my ground, it should go away. 50 millivolts, and we have a light, right? Drops to 50 millivolts. Bad ground, right there at that connector. So that whole connector needs to be changed. And the reason why I wanted to find it like that is because of that. Like if one of those is bad, dude, there's gonna be more than one that's bad. I'm just gonna wiggle them all. They're still tight. Just that one. So I'll ask Danner what he wants me to do. I just made the decision without you. It really needs this whole eyelet changed, in my opinion. But it only has one broken wire. I tugged on all the other ones.
So you just put another eyelet?
I'm just putting another eyelet for this ground over top of this one. All right, let's see if they work. Both lights on. Why is that blinking fast? There we go. That was weird. It was like a logic circuit in the front control module is what that would have been. That's pretty cool. As opposed to why it was blinking fast for a second. All right, I'm gonna get a shot of my repair. All right, so I just changed the one. I didn't change the rest of these. I tugged and pulled on them. They were still in good shape. I was comfortable with this eyelet still. This is the one I changed. There's enough slack still in the harness. This harness doesn't really move anyway. If this does come back, we'll have to buy a bigger eyelet. We did not have one, so this was the repair that we chose to do today. But if this happens again, we'll have to replace this whole eyelet. Not a big deal, but classic bad ground symptoms. And the rest of this, I'm just gonna put the coolant bottle and everything back together for my brother. You guys saw the final result. I guess, yeah, I already have the screen recorder off. I showed you what the ground would look like with a good ground, so there's no reason to revisit that either. Hope you guys learned something from this. Back feed from bad grounds. They can really be confusing first time you see them. Guys, thanks for joining us. We'll see you next time. Actually, we got one more to do, Caleb. We gotta go back to that evap one, but we're done with this Magnum right now. Now we gotta go back to the evap.